Series and parallel circuits are going to be what we consider today for our wiring techniques. Most larger PV arrays are going to use combinations of both of these. But in order to explain how they work, we're going to look at them individually and then together. A series circuit is one in which all sources of voltage production or consumption are in line with one another, or in series. If I take two solar panels and I put them in series, that is by connecting the negative output to the positive output of the next neighboring solar panel, I will place them in series. What takes place when I do this? I increase the voltage. If I had 30 volts from one solar panel and 30 volts on the other, once I've placed these two modules in series to one another, I have 60 volts of production. I do not increase the ampacity of a module when I place it in series. That's what happens when I place it in parallel. Series only increases the voltage. Sometimes it's nice to work with higher voltages. Line loss is an effect that takes place over the voltage of a circuit. So if I'm running a long distance, it's more amicable to do so at a higher voltage. I like to run around 600 volts DC if I could. It's very practical because I won't lose as much energy over long distances. However, I might not have enough amperage in order to be able to affect the outcome that I want to achieve. So let's look at that. Remember, two solar panels in series will increase the voltage of those solar panels. The same thing takes place in the world of batteries. If I have a 6-volt battery and another 6-volt battery, and I place them in series, I'll end up with one 12-volt battery bank. It's going to be the combination of the two. Why might this be attractive? Well, if I've got 6-volt batteries but I want to run 12-volt lighting systems, I need to connect them together appropriately. This is why we have series and parallel options. Placing them in parallel will increase the ampacity, whereas placing them in series will increase the voltage. So let's consider parallel now. This is when one runs into a junction box as well as the other. I take the negatives, or the black wires, and I put them together, and then I have but one black wire coming out. It carries the composition of the energy across both those wires collected together. So if I had 2 amps in on one wire and 2 amps in on the other wire, the one black wire that comes off of there that contains the paralleled energy will have 4 amps. See how that works? I haven't increased the voltage of these modules by placing them in parallel. I've combined the amperage that's being produced into one wire. This is very important to understand because sometimes I can't increase the voltage beyond what I've done already. Lots of charge controllers have a maximum input capability of maybe 150 volts. Well, what happens if I need more than 3 solar panels and they're 37 volts apiece? I have to parallel the next string to it. So I'd increase my voltage to round 150, and then for the next addition of modules, I'd have to place them in parallel with the first one. That would create more amperage there at a similar voltage to the parallel string that's beside it, and then combine it together. This is how I design well-balanced systems. I have to use compositions of both series and parallel to affect the outcome I can use, because sometimes I need higher voltage and sometimes I need more ampacity.